Section 2.2 notes, we will talk now about how we can combine statements, elemental statements, into more complicated statements. And we will look at the operators and, or, and not. So the objectives are to combine statements using and, or, and not, to read and write truth tables for and, or, and not, and to break down and, or, and not statements into their original components. So objective 1 and objective 3 are the reverse operation of each other. Notation. The statement P and Q is noted P and Q in symbolic form. This, by the way, is called a conjunction, if you want to know. We'll see an example here. Read these statements and determine whether they are true or false. So there are 4 statements, and they are very obvious. We'll discuss whether they are true or false. Statement S sub 1, 2 is even and 3 is odd. So let's look at each elemental statement. 2 is even is true. 3 is odd is true. So the entire statement S1 is true. S sub 2, 2 is even and 3 is even. Now 2 is even is true, but 3 is even is false. So the entire statement S2 is false. If a statement is not entirely true, then it's false. S3, 2 is odd, that's false. So already we know that S sub 3 is false, but let's read it entirely. 2 is odd and 3 is odd. This is false because the first part of the statement is false. Finally, S sub 4, 2 is odd and 3 is even. This is false as well, obviously. So what did we do here? We looked at 4 statements, and they all had in common that we're talking about the numbers 2 and 3. They all connected with and they are going through all the possibilities of even and odd. And that's something that's really important and we'll do all the time. And the reason why it's important is that what's going to come out here is always going to be the same. If the first statement is true and the second statement is true, when we connect them with and, then the whole statement will be true. Now if the first statement is true but the second one is false, then the whole statement is always going to be false, etc. So when we want to formalize that, we usually do it with a truth table. A truth table is a table summarizing the truth values of statements. Here's the truth table for P and Q. So if the first elemental statement is true and the second one is true, then the whole statement is true. 2 is even, 3 is odd, so 2 is even and 3 is odd is true. 2 is even, that's true. 3 is even, that's false. Therefore, 2 is even and 3 is even is false, etc. We'll do the same now with P or Q. The statement P or Q is noted like this in symbolic form. It is a disjunction. And by the way, if you think of this symbol as similar to the union in Venn diagrams with sets, then you're doing something very important and very good. Likewise, earlier, P and Q can be seen as the intersection of 2 sets, and the shape of these symbols are kind of similar, so it's handy to remember that. One note before we go on, because it needs to be clarified in logic. In English it's not very clear. If we have a sentence, let's read this sentence first, and I think it'll help us all understand. Pass this course or you won't get credit for it. When a teacher says that, what they really mean is either you pass this course or you won't get credit for it. It's either or. In logic, this is not what we mean when we use the word or. When we use the word or in logic, it means either or both of them. So let's read the note. P or Q always means one or both in logic. In case we want to express a sentence like pass this course or you won't get credit for it, we need to always specify it in one of the following ways. Either P or Q, exactly one of P or Q, or finally P or Q but not both. And this is really what we mean when we have these sentences. One of them is going to happen but not both. So, the statements here follow the same pattern as earlier, and we'll see how it changes the combined statements in terms of truth values. 2 is even or 3 is odd. That's true. S sub 2. 2 is even or 3 is even. Now, 3 is even is false, but given that 2 is even is true, then we can say that S sub 2 is true. It's an or, it's not an and. S sub 3, 2 is odd or 3 is odd. Given that 3 is odd is true, S sub 3 is true. And finally, S sub 4, 2 is odd or 3 is even. There's nothing to save here. 2 is odd is false, 3 is even is false as well, so the statement S sub 4 is false. We can summarize that in a truth table, just like we did earlier for P and Q, but this time it changes the third column. So the first and second column should always be written exactly in this fashion. You should never mix around. It's always P is true, true, false, false, Q is true, false, and you should not switch rows. And the consequence of doing that is we can always be confident that the column for P or Q is always going to look exactly like this. And very soon you'll do that instantly without even thinking. So if both P and Q are true, then P or Q is true. If P is true and Q is false, then P or Q is true. If P is false but Q is true, then P or Q is true. The only case where P or Q is false is if both P and Q are false. Lastly, the statement, it is not true that P is called the negation of P. And it is written like this or like that. We just say not P in symbolic form. Our textbook uses this notation, by the way. But many times, if you look at other textbooks or on the internet, you'll see this symbol for not P. So you notice here that unlike earlier, there's only one statement, P. So it's a smaller truth table. Let's just first look at the statements. 2 is even, that's true. And therefore, it is not true that 2 is even is false. The truth table is obvious. If one of them is true, then the other one is false, and vice versa. So finally, if we want to break down statements into their elemental statements, their original statements, there are sometimes many ways of doing that. We'll see how it works. Express the following statements in one of the forms P and Q, P or Q, or not P. State exactly what P and Q stand for. Example 1. Seniors work on early applications or regular applications. So there are two statements here. P is seniors work on early applications, and statement Q, seniors work on regular applications. And if we put them together, we will write P or Q. Some seniors work on early applications only, some seniors work on regular application only, and some seniors work on both. Second example, X is less than or equal to Y. How could we do that? Well, we just make up a statement that is x is greater than y, and then x is less than or equal to y corresponds to not p. So that's it for section 2.2. We saw 3 ways of making more complex statements from simple statements using and, or, and not. Thank you.